There we go. Okay, so the difference quotient. The difference quotient is f of x plus h minus f of x over h. I want to show you how that is this formula in a different form. What is that formula? Slope. All the difference quotient is slope. So let me draw you a little function here. Should we go red? No, slope was red. We'll go green. All right, here's my function. Let's call it f of x. Okay. I'm going to pick 2 points. Let's call the first point, this point here, let's call it x. And if I plug x into f of x, guess what I get out? I get out f of x. Okay, so here's x. You're used to seeing y or something like that. I'm just going to call it f of x. Right? It's just the output. And then I'm gonna move over h units. I'm going to add h to x. So what would this point here be? X plus h. Hello. Hello. Okay, now when I take that input and I map it onto this point, its output will be f of x plus h. F of x plus h. So this point is x plus h, comma, f of x plus h. 6. So if I want to find the slope between those 2 points, from there to there, I'm going to take y minus y over x minus x. So y minus y, here we go, f of x plus h minus f of x. Oh, hello. And x minus x, x plus h minus x. Oh, look at that. What do I get on the top? I get what I had, which is f of x plus h minus f of x. And on the bottom, the x's cancel and I get h. That's just the difference quotient. That's all it is. It's generalized. Right? And what we do in calculus is what we're interested in is what's called instantaneous rate of change. Creative pen, where are you? Okay. I want to know the slope at exactly that point. So what do? I make h really, 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 really small. As I make it smaller and smaller and smaller, that slope gets closer and closer and closer to the slope at that special point. That's calculus. That's all it is. What? It's just slope? Yes. That's all it is. Okay, we're going to pause for a second. So, hello children, we'll see you in a minute. Although it'll feel like half a second, because you'll just keep it running and then you'll hear me again. Okay, we're back. That was quick. I'm going to take f of x and divide it by g of x. Well, all that I'm going to do here is place f of x, which is x squared, over g of x, which is 3x minus 1. I can't simplify that further. There is going to be temptations to reduce the x's, but you can't do that. That is not a law in algebra that we can do. So this is complete. Right? This is f divided by g of x. If we want to find the domain, we have to look at one of two things. Do we have an even root? Give me an answer. Yes or no? Do I have an even radical? Do I have a square root or a fourth root or a sixth root or an eighth root? No, I don't. I have x squared. I don't have square root of x. Right? So the only thing that I'm going to then look at now is the denominator. I don't want the denominator equal 0. So the domain of f divided by g of x will be everything except for what value? Yeah, 1/3. If x equals 1/3, we got problems. Then we're going to be dividing by 0. That's a terrible color on this. Maybe it's not in the video, but it is in the classroom right now. How did I find that? I set that equal to 0 and I solved. The only way to make the denominator equal 0 is if x equals 1/3. We're going to go backwards and do f minus g of x. So f minus g of x will equal f of x, which is x squared, minus g of x, which is 3x minus 1. I already see where the mistakes are going to be made. Someone will do this. Someone will do that, and that is wrong. Distribute that negative sign to both the 3x and the 1. There's our function. That is f minus g of x. Domain here, anybody just want to holler it out? Say again. Yes, all real numbers. Domain, you could do this. All real numbers, that will work, or negative infinity to infinity. I'll take that. We're used to binomial multiplied by binomial. Gosh, why is that so hard to say? And then we FOIL, right? If you have trinomial times binomial, then we do a different acronym. And I know that on the street, this acronym has other meanings, right? But we are going to take the binomial, yeah, funny, first, middle, last. Let's do it. That's negative x to the fourth plus x to the third plus 6x squared. I am going to do first, middle, last again. Well, I want green, or let's go red. With a negative 9. First, middle, last. And I'm going to do this in a special way that I like. You don't have to do it this way, but I'll get a 9x squared. I put that there, so I'm going to add like terms. And then I'll get a negative 9x and a negative, is that 54? 9 times 9 times 54. Yep, that's my 9s. And then I just combine like terms, so I get negative x to the fourth plus x to the third plus, 15x squared, combine like terms, minus 9x minus 54. And that is f times g of x. Domain, like we said, domain will be all real numbers, seeing that there are no radicals, even radicals that is, and no denominator. Oh, and look at what appeared here. F of x is negative x squared plus x plus 6. I factor out a negative symbol, and I'm going to factor this thing. If I factor that, I get x minus 3. This right here. Hello. X minus 3, x plus 2, and I brought that negative symbol out. I'm dividing it by g of x. This by the way, is this problem right here. I'm dividing by g of x. I factored x squared minus 9, and looky what goes away. Although I do have to keep in mind something here. So the function itself could be written like this. This could be f divided by g of x. Simplified, right? But we do have to consider this factor right here, y. When we think about what, Eddie? Right, this is a hole in the graph. Right, there's a hole there. So the domain, we have no even radicals. We saw that in the earlier problem, but the domain is going to be where the denominator equals 0, right? We can't have the denominator equal 0, and guess where that happens? At two values, positive 3 and negative 3. So here we go. We're going to be smart children. We're going to write down the correct numbers. There we go. That's our domain. Or, Joey, you got a different way to write it? It depends. In this case, it's a hole. Yep. Yep. This is an asymptote. Negative 3 is an asymptote. Because it shows up on the bottom but not the top. Holes show up on the top and bottom. Right. Okay. So there's our domain. Let's continue. Here, folks, is f of x divided by g of x. Do I have a denominator? Yeah, I got two of them. Sick. Okay, is there a way for me to make 1 over x minus 1 equals 0? The answer to that is no. Because it'll always be 1 over something, right? There is a way for me to make x minus 1 equal 0. If x equals what? 1. Great. So we know our domain already. Our domain is going to be everything except for 1. That's not an 8. Okay, that's an infinity. However, when I simplify, if I ever divide by a half, I'm not really dividing by a half, I'm multiplying by what? 2. Right? So if a teacher ever says, hey, take all the money in your pocket, divide it in half, and give it to me, they're really saying, go home, find as much money you have in your pocket, and give both of those to him or her. Right? They're saying double it. You'd be like, what? Only half my money? You only want half of it? No, they really want you to double it and bring it back because they don't make any money. So in actuality, right here, I'm going to take and I'm going to multiply top and bottom times x minus 1 over 1. Right, I'm going to get rid of the denominator. So if I multiply by x minus 1 over 1, this goes away. So the denominator is just 1. And on top, I get this thing. You can FOIL that out if you want to. There will be a child on the test that does this. And I'm going to lose it. Yeah, it's cool. Those are good algebras. No, don't do that. No, that's bad. That's bad. It's really x squared minus 2x plus 1. You could, either of these two would be acceptable answers for f times g of x. Whoa, f divided by g of x, sorry. Divided by g of x. Okay, cool. This problem right here is Mark Wahlberg in the hallway with a ghillie suit on, sniping patellas.
Isn't Mark Wahlberg the Apple guy?
The Apple guy? No, that's Mark Zuckerberg.
That's the Facebook.
Whatever. Oh, yeah. Okay, so he's Facebook. Okay, hold on. I'm recording. Let's do some work here. This is a snipe. Denominator can't equal what? 0. But then the denominator also in this case has to be greater than or equal to 0. Wait a minute. So I want x plus 1 to be greater than or equal to 0. However, since it's in the denominator, I get rid of part of that. Can't equal 0. So the domain x is greater than -1. There will be straight up snipes on the test. Someone will mess that up. Don't be the one. Or I'll get you an old New Kids on the Block cover photo of Marky Mark. Yeah, and the Funky Bunch. Okay. Would that be an acceptable way to write that function? Yeah, you could do that. That's fine. Yeah. Cool. If f of x equals 6, right, what would f of a be? What about 6? What would f of 2 be? 6. What would f of x plus h be? 6. This input, this value right here, right? This value, and this value, they're all supposed to go in for x. There's no x. So this graph is a horizontal line at y equals 6. What's the slope of that line? Slope of that line is 0. Now watch. Here comes the difference quotient. We said f of x plus h is 6 minus f of x over h. What's 0 over h equal to? 0. Pyong. That one's filth. So simple, yet so filthy.